Physics students, we're on chapter 4. This is unit 3. We're talking about forces. And today I just want to go over friction, the force of friction. But before we talk about friction coefficients, I just want to define what friction is. We use this word, but we need to have a working definition. Force that acts opposite the motion between two materials moving past each other is the definition friction. We're going to use, there's different types of friction. There's static friction, the resistance force that must be overcome to start an object in motion. And then kinetic friction, which is the resistant force between two surfaces already in motion. So, as you can, as you've I'm sure experienced, you have to apply more force to get something moving, but once it moves, it requires less force, and the force required to get it moving is the static friction force that you're trying to overcome, and then the force of friction that is just kinetic friction is what you're trying to overcome while it's moving. The initial push to get a car going is greater than the force necessary in order to get it rolling. Perhaps you've experienced that. Let me show you what that might look like in a graph, just for illustration purposes. If we had force on the y-axis and we had time, we're applying force over time, and you apply force, and then what happens is it starts to level off. Well, this would be what we would call the force of static friction at its maximum. Connect the dots for us. We have constant velocity here. We're leveled off, and this is force of kinetic friction here. And as you can see, it takes less force for the object to move after the friction of the static frictions have been overcome. So generally, we can say that the maximum static friction is going to be greater. Is greater than kinetic friction. I think it's pretty safe to say that. We'll always experience that. So if we have let's say I don't know, we have a book sitting on a table, and we apply a force to it to move it. Friction is always going to be force of friction. The force of friction is always parallel to the surface in a free body diagram, as I'm showing here, opposite the direction of motion, as you would expect, just to be perfectly clear. So friction is always parallel to the surface and opposite the direction of motion. So this is the applied force, and then this would be the friction force. So the magnitude of friction is proportional to the normal force, as you can imagine. We have gravitational force, and then we have a normal force. So we have to overcome that normal force in order to get the object to move. So the magnitude the magnitude of friction is proportional to the normal force. Right? So friction equals the coefficient of friction times the coefficient of friction times the normal force. So, as you can imagine, friction depends on the surface sliding past each other. Not all surfaces have the exact same amount of friction. That's why we go to purchase shoes that have more friction than others, or we have rubber tires. Not every surface has the exact same amount of friction. So friction depends on the surface. Right? So we use the Greek letter mu. We use the Greek letter mu, and you'll either be given the coefficient or you'll have to calculate the coefficient. And chances are we'll have to calculate the coefficient. So as you can imagine, two perfectly smooth surfaces are going to have less friction than two rubber surfaces. So the coefficient of kinetic friction, so that would be the coefficient of kinetic friction. Remember, kinetic friction is the friction of that the body experiences after it's already started moving, is the force, the kinetic friction force over the normal force. All right? So this is the normal force, and this is the kinetic friction. Right? So friction can be calculated. Friction can be calculated directly, or what we could do is we could use our coefficients. If we're given the coefficients, we may or may not be given the coefficients. So if we know the coefficients, friction equals just the friction force equals the coefficient of friction times the normal force. All right, that's assuming that we're calculating friction directly, friction force. We're calculating friction force directly, assuming that we have the coefficient of friction. And let's not assume that we will. But let's try an example where we'll have to calculate. Let's try an example where we'll have to calculate that coefficient of friction. Right? So we have a crate that is 24 kilograms. It requires 75 newtons to move it. So if it requires 75 newtons to move it, then that's the force of the static friction maximum. And we'll find the coefficient of static friction between the floor and the crate. We could do that because I just gave you the equation. And it only takes 53 newtons to keep a crate moving. Well, chances are we're going to have to find the coefficient of kinetic friction as well. So I just put this on here to show you that no two surfaces, as smooth as you think they are in fact smooth, but those contact points make the static friction more than the kinetic friction, because once it starts moving, they slide much better. So here's our crate. And we basically have 75 newtons to get that thing going, and we have the force of the static friction max that we're going to have to overcome, and we have 24 kilograms is our mass, is what we have so far, right? So, well, let's get cracking. We have force equals mass times acceleration, and we need the normal force. So the normal force equals 24 kilograms times 9.81 meters per second squared, and so that's going to be the normal force, which is 235.4 newtons. So we have force normal equals 235.4 newtons. And if it takes 75 newtons to move it, therefore the force the static force of friction maximum must be 75. So we have force of static friction max is 75 newtons. So the coefficient of static friction is going to be, as I just showed, is force of static friction maximum divided by the normal force. So it's 75 newtons divided by 235.4 newtons, and that would be 0.32. And that would have no units. We would lose all the units. But anyway, we have a coefficient. We have a coefficient of friction which would be 0.32. So that's for the static friction. Now we could do the same thing for the kinetic friction, because the kinetic friction over the coefficient of kinetic friction is the force of friction of kinetic friction over the normal force. And so we already said that it takes 53 newtons to keep it moving. So it's 53 newtons divided by the normal force, which is 235.4 newtons. And so if we divide that, it'll be 0.23. And again, there's no units. So our mu of k equals 0.23. So that's just to get the coefficient, right? Now that we have the coefficient, what we're going to be asked to do is we're going to have some equations where we have to plug that coefficient into force of friction equals mu times the normal force. And so you'll do the first step to find mu, and then you'll do another step to find another force in order to get the overall force, I'm sure. And rest assured that there's going to be some angles involved. There's going to be some angles involved, aren't there? Okay?